Today we're going to be working on bullet trajectory to try to figure out at what angle or what height a bullet came in and struck an individual. So we're going to work on a lot of problems like this. I believe there's going to be 8 front and back. And we can just read through these scenarios and put together how this works. I'll go over how to do this example problem together first and then go from there. So the first problem is going to be about a victim who was shot by a bullet that came through his front car window. Witnesses saw a muzzle flash from a building that was 40 feet away. The angle of trajectory was determined to be 2 degrees by using the point from where the driver's windshield was broken and the point where the bullet entered the victim's head. Use the law of tangents to determine the height at which the victim was shot from. It also gives us one more important piece of information, which is the height from where this bullet actually hit down to the ground over here. So it gives us a bit of a drawing to figure out how to work this whole thing. And it also gives us a formula to work with right here. Tangent of theta is equal to opposite over adjacent, or as we'll call it, B over A. Now I'm going to put together how to make this all work, but I don't have a lot of room here, so I'm just going to do this on a separate piece of paper. If you would like to have a space, if you just look on the very back, on the back of the page at the bottom, there's plenty of space to do that same thing there. So let's put this together based on the information it gave us. First thing that we'll put together is our formula. Our formula was tangent of theta is going to be equal to 2 variables, B and A, V over A. In order to make sense of this, let's put this into a drawing. I'm going to start out by drawing out an individual here. And I'm going to draw that he is on the ground. It had him driving on the ground, but as long as we have a distance between him and the ground, it will be just fine. I'm then going to have a building. It's a beautiful building here. And we're going to have a shot happening somewhere from some height on the building down towards the individual. And that's going to be the information it's going to be giving us. Now, we're going to need a few things. First, I'm going to be making a bit of a triangle from the individual over this way. And that's going to be one of the measurements they gave us. For the sake of this, I'm going to be calling it A. So whenever we talk about A, I'll do this in red so that we have a little bit of consistency. So that's going to be our distance from here where the person was hit over to the location where it was actually shot from. So the horizontal distance from here to here is going to be A. Now, it gave us another variable. That is the angle from where the bullet actually traveled down to that new imaginary line we put together. That's going to be our angle theta, the Greek letter theta. Once again, whenever we talk about angle, we're going to call it theta, and I'm going to use this light green color in order to go over it. So that is our angle. Now, what it's asking us to solve for is going to be the height. So we need to go from where that shot was taken, the vertical distance here, that height to here is going to be our variable B. B is going to be our height, but that is only going to be the height from where the shot was taken here down to our plane at which the person got struck here. So whenever we're talking about B, I'm going to put it in blue so we know that is going to be our height. There's one more it gave us at the end, which is going to be the height, not from where the person, like how high the person is, but from how high, like not like their height, but the height from where they were struck down towards that ground. I'm going to put this one in orange, and I'm going to call this H for height. So height from strike to ground. Okay, with that, we have all the information that we need in order to do the first problem. But our formula is not leaving the one question we have, because it provides us our distance, it's providing us our angle, and it provides us our height from the strike to the ground. So we're going to be trying to answer what B is, what the height from where the person shot down is down to the ground. So we need to rearrange this formula to work for us. The way that we're going to do that is we need B by itself. In order to get B by itself, we're going to need to, from this formula here, multiply both sides by A, which will get rid of A here and make it so that we have B is equal to the tangent of theta that we had before, and that's going to be multiplied by the variable A, the distance from here to here. Now, to put this into a formula that we can work with, we're going to be going back to the numbers that we've had before. So the first number that it gave us is our distance. Our distance is going to be that the building was actually 40 feet away from where the person got hit. So I'm going to lightly put 40 feet right here because that's going to be A. Our angle is a very tight angle. It told us it was only 2 degrees. 2 degrees between the elevation here and our straight line that we put here. B, our height, we don't know. That's our variable that we're going to be solving for. It did give us h in the image, but not in the problem. That height for this one is that he was struck when he was 4 feet from the ground. So 4 feet from the point where it actually hit down to the ground down here. So we need to use this formula. So how we apply this is B is going to be equal to the tangent of theta, which for us is going to be 2 degrees. Now we need to multiply that by A. So times A, our distance, which is 40 feet. Now all we need to do from here is actually plug this into a calculator. So I know a lot of us don't really have calculators with us, so a lot of us are going to be trying to do this from our phone. So I'm going to show you how I'm going to do it from my phone. First thing is I'm just going to open up the calculator app. You can do this from your computer, you can do this from a calculator if you have it with you, but the first thing you need to do is make sure that it's in the right setting. So if your calculator looks like this, let's go ahead, the calculator button down here. We're going to change it to a scientific calculator because we need access to the tangent button. The second thing I'm going to need to do is check which version it is on. Because we're doing a little bit of trigonometry, it does matter what setting that we're on. So I need to be set to degrees. So I'm going to hit this button that says DEG if it's available, and it'll make this disappear. If it's on the wrong setting, it'll be called radian. If it is set to RAD, the radian setting, I will need to remove that. If it is not set correctly, you will get a different you'll have a different answer than I have here, and you'll need to change your settings and go from there. Now, I'm just going to put this directly into my calculator. So I need to start up by hitting the tangent button, T-A-N, and I'm going to do the tangent of the value of 2, I'm going to end my parentheses here, and multiply that by 40 times 40 equals. Now it's going to give me a long number. I'm going to keep it simple and I'm going to round it to the nearest tenth for this one. So now I have that B is equal to 1.4. So since we're measuring distance of height from here to here, that's going to be 1.4 feet. Now that's not my final answer because that's only going to tell me from here to here. That doesn't tell me the height from which it was actually taken from. So to find that final height, I need to go from here, not down to here, but all the way to the ground. So I just need to add it to something. So my total height that I'm going to be looking for is just going to be that B value, 1.4 feet, and I need to add it to the distance that it gave me from where the person was struck down to the ground. 1.4 plus 4. Probably do this without a calculator, but for the sake of consistency, let's do 1.4 plus 4 additional feet. That's going to give me a calculation of 5.4 feet from where the shot was taken down to the ground. Now, to apply some logic, they're not going to be high up in the building. It sounds like they're shooting from 5.4 feet. They're probably going to be staying on a ground level, maybe on like a step or something. So this is going to be shooting that we're not going to be looking for someone high up in the building for. We're looking for someone on the ground floor. Now, to look back at our assignment, our problems to solve, number one, problems to solve are number one is going to be asking something very similar. On a quiet day without many witnesses, a 4.5-foot victim, that's not telling us its height. It's worded interestingly, but a victim is struck 4.5 feet up by a sniper that was in a tower 780 feet away. So quite a distance from where the person was hit to the tower. If the angle of elevation is 48 degrees from the victim, at what vertical distance did the sniper shoot from? You'll be able to use this exact same formula and just use the different values to place into this to figure it out from there. I'm not going to go over that one with you. I'll let you solve that one on your own. I will go over number two with you, however. Number two asks, an armed gunman shoots a victim who is 5.9 feet tall, or strikes him at 5.9 feet up at least, from the roof of a building that is 146 feet away. If the roof of the building was 385 feet high, at what angle to the horizon would the bullet have been fired? Now, it's not asking us the same question that it asked here. Here, we solved at what height was it shot from. It actually gives us that value. Instead, it's going to ask us at what angle. So we need to answer a different question. So I'm going to get rid of my values here. I'm going to ignore that this is all here. Just get rid of this for right now. Get rid of these values, get rid of these values. And I'm going to put in what it gives me. So it gives me that the person was struck at a height of 5.9 feet. So I'm going to put 5.9 feet here. It's also going to give me that the roof of the building was actually 385 feet high. From here to here was 385 feet. It also gives me that the building is actually 146 feet away. 146 feet. Actually, I put that in the wrong spot. Let me put that over here. 146 feet. So in order to solve for this one, I'm not going to be able to use this formula because it's asking for something else. Instead, I'm going to use a formula where I can solve for this angle instead. So my new formula is going to be answering for theta. Theta is equal to rearrange my formula, all I need to do is get tangent on this side away. So all we need to do is take the inverse of this tangent. So all I need to do is tan inverse. So the inverse of tangent of b divided by a. So it's going to require a slightly different button on our calculator to solve for this one. So let's put together our formula over here. Our formula that we have now is theta, our angle, is equal to the inverse of tangent, tan minus 1, of b. We don't actually have b right now. What we have is that the building itself is 385 feet high, and then the person was struck from 5.9 feet high. So before I actually put b, I need to solve for b. b is equal to 385 feet of the actual height of that building minus this distance right here. We need to take this off first, which was 5.9 feet. So let's do that on here. 385 minus 5.9. That's going to give us that b is actually 379.1. This is what I'm going to have to do anytime that tells us how high the building is from the ground and not from the location, not from the horizontal location at which the person was struck. So now that I have b, I'm going to put that theta is equal to tangent minus 1, or inverse of tangent, of 379.1 over, I'm looking for A. A was 146 feet. So that's going to give us that theta is equal to what? Now, in order to do that, I'm going to have to use a slightly different button because tangent is not what we're looking for. So we're looking for the inverse of tangent. In order to do that, it really depends on your calculator. On this one, there's no tan minus 1 button, so I actually need to hit second, and that changes these buttons to something slightly different. Oops. So that button is going to be tan minus 1, second tan minus 1. It gives me a tan on this. That's going to be what we're looking for. Inverse of tangent of B over A. 379.1 divided by 146. It's going to give us an answer of 68.9 degrees. And that's going to be the answer that we're actually looking for. 68.9 degrees. So we've gone over the example problem. We've gone over 2. There's one more interesting one that it is going to ask you to do. It might ask you how far away was the victim instead. So I'm going to look at number. Oh, I'm sorry, I don't see which number it is. Not waste your time. I'm going to give you the formula for if it's asking for the distance away. That's the only formula we haven't gone over. So if it does ask you for that, it's going to be A is equal to B over the tangent of theta. So the same kind of idea, except for if it's asking you from here to here, you're going to use this formula instead. For ease of convenience, I'd actually write all 3 of these formulas somewhere near the top of your paper so you can refer back to them very quickly and easily. Do your best, help each other out to the best of your ability, and please don't be the problem today.